The first thing is a definition. We have been doing equations this whole time. Equations have equal signs. You have some variable expression equals a number. And so you're solving for what it equals. Your answer is one number. One number makes the statement true. An inequality is a mathematical sentence stating that two quantities are not always equal. All right? They're not always equal. So exactly what it sounds like. Equation means you have an equal sign. Inequality means you have something other than an equal sign. And then they give you all the different types of inequalities. So you do need to know these symbols and what they mean. Hopefully they are not new to you. This first symbol means less than. They give the example, 4 is less than 6. The next one, greater than. 5 is greater than 3. Here we go. We have an equal sign with a line through it. It simply means it's not equal. -2 is not equal to 4. When you have the greater than and less than signs with a line underneath it, it means that it can be that symbol or it can also be equal to. So this first one, less than or equal to. -1 is less than or equal to 8. They could have said 8 is less than or equal to 8. That is also true. Greater than or equal to, same thing here. 6 is greater than or equal to 0. They could have said 0 is greater than or equal to 0. It can be either the greater than or less than. It can also be equal to. All right. And then this last thing that they tell us, trichotomy property. If A and B represent two real numbers, one of these must be true. Either A has to be equal to B, A can be greater than B, or A can be less than B. Those are your only options, all right? And yes, you have less than or equal to, but it falls into those three groups. They're either going to be equal, greater than, or less than, all right? So let's look at just what these inequalities mean. State an inequality equivalent to X is not less than or equal to Y. Well, if X is not less than or equal to Y, you could just say that X is greater than Y. All right, X is greater than Y. Let's look at the next example. Determine if these are solutions. Now, for greater than, less than, for inequalities, you will have a set of numbers as your solution. When we did equations, you should have gotten one answer. If you got multiple answers, you probably did something wrong on the equations that we've done so far. But for inequalities, your answer is actually going to be a set of numbers. So it's very possible that all three of these could make some of these true, or none of them could make it true because it's a set of numbers. So the first one, they want us to look at 2, 3, and 4 in this inequality. Does it make it true? Well, we're going to put in 2 plus 3 is greater than 6. And it's not true, right? So that's not true. 2 plus 3 is not greater than 6. This one would be false. Look at the next one. 3 plus 3 is greater than 6. Also not true. That one is also false. And then if we plugged in the last one, 4 plus 3 is greater than 6. That is true. All right? And so there are going to be times when multiple work. Look at the next one. 6 is greater than or equal to 2 times 2. Yes, that is true. 6 is greater than or equal to 2 times 3. That is also true because we have that or equal to. 6 is greater than or equal to 2 times 4. That is false. And so you could have multiple answers here. So you will have a set of numbers as your answer. And so when you do that, your answer is going to be twofold. You're going to list the variable as greater than or whatever, and then you're also going to graph it. So all of your answers will have graphs attached, number line graphs. So let's look at example 3. Look at example 3 here. Graph X is greater than or equal to -3. You have to distinguish between greater than and greater than or equal to when you graph these. And the way you distinguish is how you do your circle or your dot that goes on the number. So if you just have greater than or less than, you are going to do an open circle on your graph and graph one way or the other, depending on what it is. If you have the or equal to sign, you are going to do a closed circle and then graph the direction that you should graph. All right? You are graphing the variable. So if the variable is bigger than the number, then you are going to graph the numbers bigger than that number. If the variable is smaller than the number, then you are going to graph the numbers smaller than the number. It does not matter which side the variable's on. It matters whether or not it is bigger than smaller than the number you're talking about. So this one says that x is greater than or equal to -3. Greater than or equal to -3. So I'm going to start at -3, and I'm going to do closed or open circle here. Closed. It is or equal to. Is my variable bigger than -3 or smaller than -3? Is the variable bigger or smaller? It's greater than, so I am going to do it this way. The reason I'm using it in the terms of bigger and not greater than less than is because sometimes they will write it like this. -3 is less than or equal to x. And very often I will have people graph that incorrectly because they see the less than or equal to sign. You are always asking about the variable. And so even if they write it this way, x is still bigger than -3, and it would be graphed the same way. So even if they flip which side the variable's on, make sure you are trying to always graph the variable, all right? Always graph the variable, all right? Look at the next example. X is not equal to 2. So I'm going to go to 2. I know it's not equal, so I'm going to do an open or closed circle here. Open. Is x bigger or smaller than 2? It's not equal to. So does it include numbers on the right? Is 1 not equal to 2? Yes. Does it include numbers on the left? Yes. Is, it helps to put it in the right place, is 0 not equal to 2? Yes. So actually it's going to be both directions. I'm actually going to graph everything except the 2. And you don't have to graph the whole thing. You notice that I have arrows at the end. That tells me that goes on infinitely. So you just shade one side of it, or both sides in this case, and put your arrows on both sides. It indicates I am not including 2, but I am including everything that is not 2. I'm telling you. So look at this next example, example 5. Write an inequality to describe the graph. Write an inequality to describe the graph. Well, I know that I'm at 80, so I know that x is going to be compared to 80. All right, so x is being compared to 80. Is x smaller than 80 or larger than 80? Based on the graph and where they shaded, is x smaller or larger? Smaller. Does it include 80? Is it closed or open? It's closed, so yes, it would look like that. X is smaller than 80. It also includes 80. So I am going to do less than or equal to. Less than or equal to. So we're writing an inequality that models these situations. Clearance, $9.99 and up. So I'm talking about all the prices that are $9.99 and up. So I have a variable. This is the variable that includes all the prices. I am comparing it to $9.99. Is it bigger than $9.90 or less than $9.99 for this clearance price? It's larger. Does it include $9.99? Well, they use the word and, right? So it is $9.99 and up. Let's look at the next guy. Maximum occupancy not to exceed 225 persons. So in this case, my variable is the number of people. I am comparing it to 225. Should I have more than 225 people or less than 225 people? Less. It says I cannot exceed that. So can I have 225 people or can I not have 225 people? I can, so it can include that. All right. So when you decipher these in a word problem, it's very important that you decipher it the right way, because if not, your final answer is going to be exactly opposite of what you're trying to say. So let's try some of these. Look on page 147. Phrase is at most. At most. Is that going to be less than or greater than? At most. The most you can spend is $100. You're going to spend more than $100? No, it's actually going to be less than or equal to at most. So you can spend $100, or you can spend less than 100. Is not greater than or equal to, what does that mean? Yeah, less than. Is not less than. It's going to be greater than or equal to, right? At least. You want to make at least an 85 on your test. Does that mean you want more than an 85 or less than an 85? It's actually going to be more or equal to. At least means that that's the minimum you would have. Is not as much as. Not as much as. B. Not as much indicates that it doesn't include it. Does not include it. Not as much. Right? Not as much. Is greater than or is less than. Means it's not equal to. Not equal to. It can be more than, it can be less than. It just can't be the number itself. E. Exceeds. Exceeds. Yeah, just greater than. Exceeds indicates it does not also include it. Does not also include it. Does not exceed. Less than or equal to. Does not exceed actually indicates that you could reach it. You just couldn't go above it. Okay? All right, let's look at the next one. -1. -1 minus 7. That is -8. Is that greater than or equal to -3? No, it is not greater than or equal to -3. It's negative numbers here. 4 minus 7 is -3. Would that make this statement true?
Yes.
Yes. 8 minus 7. That is 1. Would that make this statement true? Is 1 bigger than or equal to -3?
Yes.
Yes, it is. 1's greater than or equal to -3. So if I plug in -1, I get -1 is minus 7. I get -8.
Yeah, but isn't that less than negative?
We know that we're comparing it to 6. It is smaller than 6. Does it include 6? No, it does not. So that is our answer. All right. Negated. That means x is not greater than or equal to 6. Graph the inequality. I'm going to start at -2. Am I going to go larger than -2? Smaller. Larger. And I included it because it was or equal to. Define a variable and write an inequality modeling each situation. The times of the other runners if the winner ran the race in 10.85 seconds. Well, I know that I'm comparing it to 10.85. We'll just say that x is the other runner's times. Were they less than, greater than, less than or equal to, greater than or equal to if they did not win? So he's greater, but what about the other runners? The other runners are less than other runners. So we're looking at the other runners. So yes, if they said compare the winner's time, right, to the other runners, then we would be using greater than for the other runner's time. But in this case, we're comparing their time to the winner. So we're going to look at these properties. The first statement they have is 5 is less than 7. Is that a true statement? Is 5 less than 7? Yes, it is. The next statement they have is 5 plus 2 is less than 7 plus 2. Is that a true statement? Yes. I added 2 to both sides because when you add 2 to both sides, 7 is less than 9. You'll notice that when I added 2, as long as I did it to both sides, I did not change my inequality. I still had a true statement. All right? And so look at the next one. 2 is greater than 0. That is a true statement. So then what happens if we subtract 9 from both sides? Subtract 9. Well, we're going to get -7 is greater than -9. Is that a true statement? Yes. And so the rule here is exactly like the rule for equalities. If A, B, and C are real numbers or expressions such that A is less than B, or A is greater than B, it doesn't matter, then if you add something to both sides, the equality is still true. You can add and subtract both sides of an equality. It will keep the inequality still a true statement, all right? So then when you're solving these, it means you can use your same rules of solving. As long as you add or subtract the same thing from both sides, you will get a true statement. Let's look at the first example. Solve these. You are going to solve these just as you would your equations. You want to leave your inequality the way it is for addition and subtraction. So if this were an equality, I want to get my variable by itself. Same rule applies. Anytime I move it across the inequality, I do the opposite. I am adding 7, so I want to subtract 7 from both sides. Just like in an equation, it cancels out. 7 minus 7 is 0, so I have x. I bring down my inequality. 8 minus 7 is 1. And so then, because this is an inequality, you are going to graph your answers. On your handouts and quizzes, you will have a graph provided. For this one, we're going to draw a graph, open circle, because it's on my 1, and x is everything smaller than my 1. All right, look at the next one. X minus 5 is not equal to 3. Again, it's a minus 5. I want to do the opposite when I move it across. It's going to cancel out. X is not equal to 8. Again, if I graph, I'm going to graph a number line with 8 on it. Open circle on that 8, and this time I will graph everything on either side of it. Same holds true even with decimals. It is a subtracting a 0.4, so I'm going to add 0.4. On the right-hand side, it will cancel. And on the left-hand side, I'm going to get negative 0.2. This is where you need to be careful when you graph, all right? So if this is 0 and 1, negative 0.2 is going to be about there, okay? So then I know I have a closed circle at negative 0.2, all right? Is my x bigger than that or smaller than that? Is the x bigger or smaller than that? It's larger. So in this case, I'm going to graph to the right. So this is where people usually graph wrong, is if their variable is on the right-hand side, then they tend to sometimes switch that graphing. So just always ask, is your variable bigger or smaller than your number? So you know which side to graph on. You should have added 2 to both sides. You would have gotten that x is less than or equal to 5. So you should have had a closed circle on your 5 and everything to the left of it shaded. For the second one, you should have added 8 to both sides. You would have gotten that x is greater than or equal to 0, closed circle at your 0, and everything to the right of it shaded. All right, is 3 less than 5? Yes, it is. So what they're going to do is they're going to multiply both sides by 2. 2 times 3 gives us 6. 2 times 5 gives us 10. Is 6 less than 10? Yes, the equality did not change. The inequality did not change. So let's look at the next scenario here. 4 is less than 6. Is this a true statement? Now they want us to multiply both sides by negative 2. Both sides by negative 2. So we get negative 8 is less than negative 12. There is a problem. This inequality is not true. Negative 8 is not less than negative 12. It is larger than negative 12. Negative 8, however, is greater than, which is true. And so this is where we get our rule here for multiplication. If a, b, and c are real numbers or expressions such that a is less than b, if you are multiplying or dividing, by the way, since division is just the reciprocal, if you are multiplying and dividing and the number you're multiplying or dividing by is positive, everything remains the same. You leave everything the same. But if what you're multiplying or dividing by is negative, you must flip your inequality. All right? You must flip your inequality. This is only the number you're multiplying by. So it is the number that is with your variable when you start. Okay? It does not matter what the other side is. It does not matter if the other number is positive or negative. It only matters the number that you're moving across because it was right next to your variable. All right? So let's look at these examples. We have -3, x is less than -9. So I am multiplying the -3 and the x. In order to move it across, I need to divide by -3. On the left-hand side, I get just my x because this number was a negative. Because that 3 was a negative, I need to flip this sign and make this greater than. All right, and then the other side's exactly my rules. -9 divided by -3 is +3. And I will graph it based on that answer. So I will go to +3. I will do an open circle, and I will say everything larger than +3. All right, let's look at the next one. We have x over 12 is greater than -4. What's happening between the x and the 12? Division. So I need to multiply both sides by 12. Now in this case, on the left-hand side, once again, my numbers do cancel and I have just a 1x. I do have a negative here, but it is the 4 that is negative. This 12 that was with my x was not negative. Because that one was positive, I leave this guy alone. I am actually multiplying by a +12. So x is greater than -48. And so I will graph based on that. -48. I need an open circle there and everything bigger than -48. Let's look at the last one. -5/2 x is greater than or equal to 25. What's happening between the -5/2 and the x? What's happening between those? Right now what's happening is multiplication, all right, between those two. It's 5/2 times x. So in order to get rid of a fraction, remember what we do, we multiply by the reciprocal, okay? I keep that negative with it. So multiply by -2/5. I end up getting 10/10, which is just 1. And that's my whole goal here, is to make that 1x. So I'm going to multiply this side by a -2/5 as well. On the left-hand side, those actually cancel. The 2 and the 2 cancel, the 5 and the 5 cancel. I'm left with just a 1x. This one was negative. So what I am moving across was negative. So I need to change this to less than or equal to. You keep the equal to sign, but you flip the greater than less than piece. Let's look over here on the right. 25 is the same thing as 25/1. So I can cross cancel here, right? I am multiplying fractions. I can cross cancel. 5 can cross cancel. 5 divided by 5 is 1. 25 divided by 5 is 5. And I have 5 times -2. So my answer here is -10. And then I can graph. I go to -10, open or close circle here. Open or closed?
Closed.
Closed. Is my variable smaller or larger than -10?
Smaller.
It is smaller, so I'm going to go this direction. All right, let's look at these. Number 14, we have -y, or -y/4 is greater than 3. What's happening between the y and the 4? Division. So I'm going to multiply, and I'm going to multiply by -4 because I want that to be a positive y when I'm done. So I'm going to multiply the other side by -4. On the left-hand side, the -4 and the -4 will cancel. I have just y. I did multiply by a negative, so I'm going to flip that, and that's going to be -12. My number line's not quite big enough. So I'm going to go to negative 12, open circle, and everything to the left. On the next one, negative 3 times c. So I'm going to divide both sides by negative 3. On the left-hand side, I have just a c. Because I did divide by a negative, I'm going to flip that. And then negative 27 divided by negative 3 is positive 9. So I'm going to go to positive 9. It's going to be a closed circle and everything bigger than that. And then the last one. So for this one, I can actually go ahead and do something here. With multiplication, they don't have to be the same, right? You can multiply a number and a variable. That's fine. So I have 7 times x times 2 here. So I'm actually going to make this 14x. All right. Now, if I'm dividing by 14, I actually have a fraction over there. So if I divide by 14, I need to divide this by 14. All right. In this case, this cancels. But this is a fraction divided by this. What do I do when I divide fractions? What's that little rule? Keep this guy. Change the division to multiplication. How do I flip 14? What does that look like to flip 14? It's 1 over. So 1 over 14. All right, so it should look like that. Then I can cross cancel, right? 12 and 14 will cross cancel. What goes into both of those? 2. So 12 divided by 2 is 6. 14 divided by 2 is 7. Then you just multiply across. 6 times 1 is 6. 5 times 7 is 35. I had a negative times a positive, so my answer is negative here. So that's going to equal negative 6 over 35. This is a really tiny decimal, all right? It's just past your 0. So it's actually less than. So just past your 0, you're going to get negative 6 over 35. So an open circle right here, you don't have to be exact, but we'll say right there is negative 6 over 35. Open circle and everything to the left of it.